In this video, we are going to conclude this paper, which is science paper 1. So the last time we had this paper, we ended on question C, we ended on section B. So today we are starting from section C. So section C carries 20 marks, as we can see, carries 20 marks. Answer N2 questions from this section in the separate answer booklet provided. Question C1, the question reads, in an experiment to find the concentration of a solution of sodium hydroxide, 0.1 molarity of hydrochloric acid was run from uh, a burette into a conical flask containing 25 cubic centimeters of aqueous sodium hydroxide until neutralization took place. 20 cubic centimeters of acid was required. The first question, which is question C1A, Roman numeral 1, the question reads, name a suitable indicator to use in this experiment. Name a suitable indicator to use in this experiment. So the two suitable indicators that we can use. So we have seen that the type of reaction that is taking place is neutralization reaction. Why are we saying this is neutralization reaction? We are told, according to the question, that sodium hydroxide and hydrochloric acid are reacting. And we know that when a strong base and a strong acid react, neutralization takes place. A neutralization reaction will reduce the pH, or will increase the pH, or will bring the pH of the two solutions to 7, and this is called neutralization uh, reaction. So we have two indicators, two best indicators, or two suitable indicators that we can use. We can use phenolphthalein, or we can use methyl orange. Okay, so these are two indicators that we can use. So as we can see equivalence point or 7 showing the neutralization point. So therefore, we are going to choose methyl orange. We are going to choose methyl orange. We shift to the next question, which is question C1, Roman numeral 2. Describe color change that would be observed when neutralization occurred for the indicator you named in A, Roman numeral 1. Describe the color change that would be observed when neutralization occurred for the indicator you named in A, Roman numeral 1 above. So they want us to state the color change. Okay, so the methyl orange is orange in color. So if the neutralization reaction has taken place, the orange color will change to yellow. Okay, so we can see that the acids here, the orange color is showing acidity. Okay, the methyl orange will change to yellow. So yellow is showing the neutral point, or the neutral pH, which is 7. So our correct answer, therefore, our correct answer, we are going to say, even here we can see we have phenolphthalein. So phenolphthalein, for phenolphthalein we have a different case. The solution will change. The solution will change from pink to colorless. Okay, the solution will change from pink to colorless, or from colorless to colorless, or remain colorless. Okay, so since we chose methyl orange, we chose methyl orange, our correct answer would be from red orange to yellow. Okay, so we can see that yellow is showing neutralization. Yellow is showing neutralization. Let us move to the next question, which is question C2b. Question C2b, the question reads, write down the chemical equation for the reaction that takes place in the conical flask. Write down the chemical equation for the reaction that takes place in the conical flask. Okay, so the type of reaction we are talking about is neutralization reaction. So neutralization reaction, the reaction between acid and base leads to production of salt and water. Okay, so therefore we expect to see water and salt. So we are going to say sodium plus hydrochloric acid is equal to sodium chloride plus salt. So we have come up with the equation which is here. Okay, so we have seen that hydrochloric acid and sodium have reacted, and this has led to production of salt and water. Production of salt and water. Okay, we shift to the next question, which is question C. Question C, Roman numeral 1. How many moles of hydrochloric acid were used in the experiment? How many moles of hydrochloric acid were used in the experiment? Okay, so to find the number of moles, this is the formula that we are going to use. We are going to use concentration formula. Okay, concentration formula. So concentration is equal to number of moles over volume. So this is the formula that we are going to use. Okay, this is the formula that we are going to use. Or we can use mass of the solute over the volume. We can still find concentration. Okay, so therefore we are going to say we are going to what data have we been given according to our question. What data have we been given according to our question? So according to our question, we are given the concentration, which is 0.1, and we are also given the volume, which is 20 cubic centimeters. Now it is the matter of finding the number of moles using the figures given. So the molarity M stand for molarity M stand for more per cubic decimeters. So therefore, there is need for us to change uh, 20 cubic centimeters that has been given in centimeters to cubic centimeters. So we are going to say we are going to say 1000 cubic centimeters make one make 1 cubic decimeters make 1 cubic decimeters, and we are given 20 here. Here we are going to write x. Then let us do a close multiplication. We do a close multiplication. We are going to get 1000 1000x is equal to 20. Here divide by 1000, here divide by 1000, even here divide by 1000. The value of x is equal to 0.002. Okay, 0.002. So the next thing now we are going to do is to find the number of moles. So we said to find the number of moles. To find the number of moles, we are going to say concentration is equal to number of moles over volume. So concentration we know is 0.1 is equal to the number of moles over 0.002. So the number of moles therefore is equal to 0.0002. Okay, 0.0002. So this is the number of moles. So therefore, the number of moles we are going to say 0.002. Okay, 0.002. So this is our final answer. Let us move to the next question. We move to the next question, which is the question C, Roman numeral 2. Using the equation in B, calculate the number of moles of sodium hydroxide. Calculate the number of moles of sodium hydroxide. So the number of moles of sodium hydroxide. To find the number of moles of sodium hydroxide, we are going to make use of the balanced chemical equation. So we can see that the coefficient of sodium hydroxide is 1, and the coefficient of hydrochloric acid is 1. So if the number of moles of hydrochloric acid is 0.02, it means the number of moles of, let me do this. Let me do this. Okay. Good, good, good. So we are going to we are going to say if the number of moles of, so we have seen the ratio here. Here we have 1 and here we have 1. The ratio is 1 to 1 according to our balanced chemical equation. By the way, the equation is self-balanced, so there is no need for us to start stressing balancing this chemical equation. So the equation is balanced. So the one thing that we need to do here is to know the number of moles of um, hydrochloric acid, and we have known the number of moles of hydrochloric acid. So therefore, the number of moles of sodium is 0.02. Okay, 0.02. We shift to the next question, which is question C3. Calculate the concentration of the sodium hydroxide in mole per cubic decimeters. Calculate the concentration. So to find the concentration, we are going to use this formula. This is the formula that we are going to use. Okay, so therefore we are going to say concentration is equal to number of moles over volume. Okay, so the concentration is equal to the number of moles we have from saying is 0.002 over the volume we are given, which is 25 cubic centimeters. We are going to say divide by 1000. Divide by 1000. Divide by 1000. We are going to get 0. We are going to get 0.0. We are going to get 0.025. 0.025. So here we are going to have 0.025. 0.025. So if we say 0.02 divide by 0.02 divide by 0.25, we are going to get 0.08 meters per cubic decimeters. So we are told to find the concentration in cubic decimeters, the concentration of sodium hydroxide. So as we can see, we have successfully managed to answer this question. Let us come back to the question, to the main question, which is question C, question C1, question C1D. Roman numeral 1. Give a reason why the bullet was used to determine the volume of the acid and not a measuring cylinder. Give a reason why the bullet was used to determine the volume of the acid and not the measuring cylinder. So why did they use the bullet instead of the measuring cylinder? So the bullet is found here. Okay, and the measuring cylinder is found here. So why did they use the bullet instrument, which is here? So the reason why they used this one is because burette measure volume more accurate and precise than measuring cylinder. Okay, we have given the reason. The question is carrying 1 mark. We shift to the next question, which is the question D, Roman numeral 2. How was exactly 25 cubic centimeters of sodium hydroxide transferred into the conical flask? So it was transferred into the conical flask using a pipette or pipette dropper. Pipette or pipette dropper. So here we have pipette, apparatus or pipette dropper, as we can see. So this is how exactly 25 cubic centimeters of sodium hydroxide was transferred into the conical flask. So we are going to say sodium hydroxide was transferred using a pipette dropper. We shift to the next question, which is the question 2. So we are done with the first question. We now move to question C2. Question C2, the question reads, nitrogen and argon are both elements found in air. Question 2a, draw the electronic structures of nitrogen and argon. So we can see 2 marks at the end of the question. Draw the electronic structures of nitrogen and argon. So the first thing that we need to do is to identify hydrogen on the periodic table. So hydrogen is found in group 5. Hydrogen is found in group 5, and argon is found in group O or group 0. And we can see that the atomic number of nitrogen is 7 and the atomic number of argon is 7. So therefore, we are going to start with the electronic configuration. So let us start with the electronic configuration of nitrogen. So since the number of electron is 2, the first 2 electrons will be accommodated in the first shell, then the second 5 electrons in the outermost shell. Okay, so this is how our electronic structure will look like. We have nitrogen, and we can see that 2 electrons are accommodated in the first shell, then the 5 electrons are accommodated in the last shell. Let us also consider argon. Argon, we start with the electronic configuration. So we can see that the first 2 electrons are accommodated in the first shell. Then the second 8 electrons in the second shell. Then the third 8 electrons in the outermost shell. So this is how electrons in argon are demarcated. So we can see that 2 electrons are accommodated by the inner shell or the first shell, 8 electrons in the second shell, another 8 electrons in the last shell. Okay, so we have answered this question. Let us move to the next question. We move to the next question, which is question B. Question B, with the reference to the electronic structures in A, explain why nitrogen and argon are found in period 2 and period 3 respectively. So we need to understand that the the number of shells represent the periods. So we can see that nitrogen has 2 shells, hence it has um 2 periods. Then this one has 3 shells, hence it has 3 periods. So therefore we are going to say the number of shells represent the number of periods. Nitrogen has 2 shells, hence it has 2 periods. It has period 2. Okay, it has period 2 or 2 periods. Then argon has 3 shells, which means it has period 3. It has period 3. So we have answered this question. The question is carrying 2 marks. Let us move to the next question, which is question C. Question C, the question reads, the flowchart shows the separation of nitrogen and argon from air by fractional distillation. By fractional distillation. So we can see the filtered air. Filtered air, we have X, we have liquid air, we have Y, here we have nitrogen 196 degrees Celsius, and here we have argon 186 degrees Celsius. The first question, which is question C, Roman number 1, describe the processes that take place at X and Y. The question is carrying 3 marks. Okay, so the filtered air will enter like this. The filtered air will enter like this. Then the filtered air will be compressed while heats up as it is compressed. Okay, or heats up as it is compressed. Then the the filtered air, after being heated, the filtered air will be cooled, okay, while being compressed. So the compressed air is cooled, as we can see here, is cooled. Then here we can see that the compressed air is allowed to expand and turn to liquid. The air is expected to expand and turn to liquid. So the whole process starting from, let me use the most visible color so that we can see what is happening. Let me just use white. Okay, I'll use white. So we can see that from here up to here, white is also not. Let me use this one. Okay, so from here, this one is representing X. Then this one is representing Y. Okay, representing Y. So we are going to say at X, air heats up as it is compressed, and the compressed air is allowed to expand and turn to liquid. Then at Y, I said from from this one to this one, we can see that the liquid is being separated by is being separated using fractional distillation. Is being separated using fractional distillation. So we can see that nitrogen is on top and the oxygen is at the bottom, as we can see. Okay, using fractional column. So therefore, we are going to say um, at liquid air at Y, liquid air is separated using fractional distillation in the fractional column, in which boiling point is used as a criterion. So the boiling point is used as criterion. Why are we saying the boiling point is used as a criterion? So the boiling point is used as a criterion. As we can see, these two have two different boiling points. So the criteria used when using a fractional distillation is when using fractional distillation is um, the boiling point. Okay, we now shift to the next question, which is question C2. We are not yet done. Question C2C, Roman numeral 1. Give one use of nitrogen gas. So nitrogen gas is used in the production of fertilizer. Nitrogen is used in the production of fertilizer, nitric acid, nylon dyes, and explosive. Nitrogen is also used by plants. Is also used by plants. Is also used by plants, or nitrogen is used in the production of fertilizer. Then fertilizer is used by plants. As we can see, nitrogen fertilizer here, nitrogen fertilizer. Okay, nitrogen fertilizer. So therefore, we are going to say nitrogen is used in the production of fertilizers. We shift to the next question, which is question C2D. Question C2D, the question reads, argon is a liquid at 188 degrees Celsius. D, Roman numeral 1, in what state will argon be at 5 degrees Celsius? So the question is carrying 1 mark. Okay, the question is carrying 1 mark. So at what state will argon be at 5 degrees Celsius? So argon at 5 degrees Celsius, argon will be gas. Argon will be gas. Okay, we shift to question D, Roman numeral 2. Draw a okay. Let me draw draw a diagram to show the atoms of argon to show how the atoms of argon are aligned at 5 degrees Celsius. So we are from saying at 5 degrees Celsius, argon is a gas. Argon is a gas. Argon is a gas at this particular uh, temperature. Okay, argon is a gas. So the atoms or the particles in a gas are specially packed, as we can see. They are specially packed. So therefore, our answer will show particles that are specially packed. Particles that are specially packed. So we are done and dusted with this question. Now let us move to the next question, which is question C3. So question C3 is the last question in this paper. Question C3, the question reads, ethanol is a product of main fermentation reactions. The molecular formula of ethanol is the molecular formula has been given. Draw the displayed molecular structure of ethanol. So here, don't get confused. The question is talking about the uh, structural formula. Okay, not molecular formula, but structural formula. So it is saying displayed molecular structural structure of ethanol. So don't get confused here. The question is not talking about the molecular formula, but it is talking about the structural formula, which is here. So this is a displayed molecular structure we are talking about, not this one. Okay, so the first is the one they are talking about. The first is the one they are talking about. We shift to the next question, which is question C3b. Question C3b, the question reads, when ethanol is heated with the potassium dichromate 5, it is converted to ethanoic acid. Roman numeral 1. What type of reaction is this? Okay, so dichromate has a good number of oxygen. So the type of reaction in which ethanol is converted by potassium or ethanol is heated with potassium dichromate to produce ethanoic acid is called oxidation. So this reaction is oxidation. This reaction is oxidation. So primary alcohols can be oxidized either uh, to either aldehydes or carboxylic acid depending on the conditions. So as we can see, we have two reactions here. So this means oxidizing agent, and you should use this symbol when writing. Okay, so we have seen that the first reaction has led to production of aldehyde. Then here we have the mechanism, or we have two steps. We have mechanism or two steps. So we can see that ethanol is now being converted to carboxylic acid. Ethanol is converted to carboxylic acid. So therefore, the reaction is oxidation. So the ethanol will be oxidized to produce ethanoic acid. We shift to the next question, which is question we shift to the next question, which is question Okay, which is question B, Roman numeral 2. Give one safe rule to be observed when handling ethanoic acid in the laboratory. So ethanoic acid is a very dangerous acid. So therefore you need to consider some protective measures in order to refrain away from the harm that may be presented by the ethanoic acid. Okay, so you need to wear protective kits. You need to wear protective kits, chemical goggles, chemical gloves, lab coat, lab coat, face shield, rubber boots, um, chemical splash suit, respirator. So these are some of the lab kits you need to wear in order um, to refrain away from the dangers of from the from the harm that may be from the adverse harm that may be posed by the laboratory, or I mean by the ethanoic acid. Wearing protective kits such as gloves, lab coat, face shield, and chemical goggles will help to prevent or to attain a safety rule when handling ethanoic acid. We are done with this question. Let us move to question C. Question C, ethanoic acid reacts with the with the ethanol in the presence of catalysts to produce a new substance. Give the name and deduce the formula of the new substance. Give give the name. Ethanoic acid react with ethanol. So the reaction between ethanoic acid and ethanol is called esterification. Esterification leads to production of ester and water. Leads to production of ester and water. Okay. So the name of the substance the name of the compound or the name of the substance that will be produced is called ester, ethyl ethanoate. So this is the name. Then the chemical formula is this one. So this is the chemical formula. Okay. So our main focus is here. The name is this one. The chemical formula is on top. So this is the chemical formula. So you are free to pause the video and write properly. Okay, we shift to the next question, which is question C3D. Ethanoic acid is a weak acid. It can react with a metal such as sodium and magnesium to liberate hydrogen gas. Question D, Roman numeral 1. Compare the rates of reaction of ethanoic acid with the sodium and with the magnesium. With the sodium and with the magnesium. Okay, so uh, the rate of reaction of sodium with the ethanoic acid is faster than the rate of reaction of sodium with ethanoic acid. Okay, so therefore we are going to say sodium is more reactive and faster with ethanoic acid than magnesium with ethanoic acid ethanoic acid. We shift to the next question, which is question D, Roman numeral 2. What would be observed when aluminium is added to ethanoic acid? Give the reason for your answer. So when aluminium is added to ethanoic acid, we are going to observe slow reaction. We are going to observe slow reaction. We are going to see white precipitate on top. As we can see white precipitate on top, and you will also observe bubbles as the reaction is taking place. So therefore, we are going to say the slow reaction, white precipitate, and bubbles are observed. So these will be observed. We shift to the last question, which is question C3D. Give one use of aluminium based on the observation made in 2 Roman numeral 1. So the question is carrying 1 mark. So according to what we have observed in this experiment, what is the use of aluminium? So is used aluminium is aluminium is used in the aluminium has a number of applications. Aluminium is used in the manufacturing of cars. Aluminium is used in the manufacturing of kitchen utensils. Okay, so aluminium has a good number of applications. It is applied. It is applied to different uh, walks of life. Now, they want us to give the use of aluminium based on the experiment we have from just observing. So, since the precipitate is being formed uh, on top of the on top of the uh, reaction, or on top of the ethanoic acid, we are going to say aluminium is used to prepare insoluble salts. Aluminium is used to prepare insoluble salts. So this brings us to the end of this paper. Let me continue in the next video.